Good evening, millennials. Today we'll look at the third problem of the biweekly Contest72, maximum split of positive even integers. This will be later added on to the LeetCode website. So, I will be explaining the shortest solution possible, the logic behind the solution, and how to write the shortest code, and the code I wrote during the contest. So, let's read the question. You are given an integer final sum. Split it into a maximum number of unique positive even integers. Okay, so for example, if final sum is 12, the following splits are valid: unique positive even integers summing up to final sum. So 2 plus 10, 2 plus 4 plus 6 and 4 plus 8. Among them, 2 plus 4 plus 6 contains the maximum number of integers. Note that final sum cannot be split into 2 plus 2 plus 4 plus 4, as the number should be unique. Remember, this number should be unique. Return a list of integers that represents a valid split containing a maximum number of integers. If no valid split exists for final sum, return an empty list. You may return the integers in any order. So if we look at the final sum for 12, we see that the output 2 plus 4 plus 6 is accepted, and the maximum of 3 numbers with sum up to 12. Also note that the order doesn't matter, so 2, 6, 4 or 6 to 4 are also accepted. Similarly, for final sum, we can never get an even integer split. And for 28, we get the answer as 6, 8, 2 or 12. Also note that others such as 10, 2, 4 and 12 and 6, 2, 4 and 16 are also accepted. And let's look at the constraints. So the final sum lies between 1 and 10 power 10. So even we can't run an order of n algorithm. So we have to run something less than that. So let's look at the logic. So we have to split it into unique even numbers, and we have to get the maximum number possible. So it's clear that since even numbers add up to only even numbers, any odd number will return an empty array. So this is one condition. Else, let's go greedily. Since we need the maximum number of integers, if we try to include the lesser numbers as much as possible, we will be able to get the maximum number of numbers, or the maximum split that has the maximum number of integers. We will get a valid split. And remember that the numbers should be unique. So our algorithm is to first include 2 and then include 4 and then include so on till we reach the number. If say the number is 8 and we include 2 plus 4, we cannot include another 2. So we shouldn't include this 4, but rather we should skip this 4 and include this 6. So let's look at how we can do that. So basically, if we are trying to include 2 plus 4, we can check whether we can include the next by checking whether the remaining sum, which is the sum of these both, and the final sum, which is the integer given minus the current sum, till this remaining sum minus the current sum is greater than the current, we can include that next integer, else we cannot. Let us look at my short code that I submitted during the contest. So we have to return a vector long of the answer. So I declared a vector long of answer, and then I tried to iterate the numbers from 2. So let my current element be 2 and the remaining sum, which is the sum after including the current element. So that was initially final sum because we didn't remove anything. So initial check, which I told, if final sum mod 2 is 0, which means that it is even, we process the elements, else we just return the answer outside of the if condition. So inside that, if the remaining sum minus the current element is greater than the current, then we can include the current element. So I just push that into the answer vector, and the remaining sum, we have already included the current element. So I just subtracted the current element from the remaining sum, and then I went on to check for the next integer, which is next even integer. So I increase current by 2. And at last we may be uh, in a position where remaining is still greater than current, but remaining minus current is not greater than current. So in that case we need to add remaining. So I will tell you a case for this. So let's take 14. So for this, first we will add 2 and the remaining will be 12, and then we add 4 and the remaining will be 8, and then if we add 6 the remaining will be 2, which shouldn't be the case because remaining minus current should be greater than current. So in that case, instead of adding this 6, we directly add the remaining element, which is 8, and 8 plus 4 plus 2 will give 14, which is our solution, and this will be one of the maximum answers possible. And with this we are able to find this within less than n, which is the final sum, because we are only iterating through the even integers, and that too up till the point where we find a valid solution. So it will be less than the order of n, and this hence will pass the constraints. And this is the shortest code I could write. If you can write a more shorter, cleaner code, please leave it down in the comments, as we are open to constructive feedback. So that is the accepted. So if you have any more doubts, or if you would like to have a better approach for this question, please try to leave it down in the comments. Please like, comment and subscribe this video for more such high quality content. Thank you.